Hello and welcome back to the IDG Corporate Update. Today I'm delighted to welcome James Bolen, Chief Commercialization Officer of Hillcrest Energy Technologies. James, thank you so much for joining us today.
Thanks for having me.
So Hillcrest is redefining power conversion technology in really significant ways. Before we jump into your exciting recent news, could you give us a quick big picture overview of the company?
So the company is based around a technology platform that's referred to as zero voltage switching generally, or soft switching. What that really means is it's a new way of converting power from DC to AC or AC to DC, which happens all over the place. It's pervasive. Inverters are all over in many different applications. So you'd be familiar with the work we've done in the EV world. And now we're moving into grid connected world, but the principles are all the same. So it's a new way of doing switching, higher efficiency and better signals. So the benefits are things like savings of power, less CO2, savings on capital costs because things are smaller and take less capital to work around and so on. So there's lots of benefits that we're seeing in the EV world already, and now we're looking at them in the grid connected world. So we'll talk more about that.
Perfect. Okay, that's a great overview of what you're doing. So just last week, the company announced that testing is underway for your grid-tied inverter. Can you help us understand what an inverter is and the role it plays in the power grid?
Sure. So inverters convert power signals from DC to AC or AC to DC. So DC is like a battery. So if you want to, like in an EV, drive a car from a battery, you need to convert DC power to AC power to drive a motor. And so that's what we've been working on a lot lately. And so you can see how you've seen already how we drive motors in cars with our inverter. So now what we're doing is taking that and moving it into the grid connected world, where we're going to basically take something as simple as a solar farm and connect it to the AC power grid. So we won't be specifically driving a motor. We'll be feeding power into the power grid. And there are slightly different application things you have to take care of to do that properly. But the benefits manifest themselves in similar ways, but there are differences for each application. So the main thing is the inversion efficiency is better and the signal quality is better. So both of those things save people money.
Very good. Now, I guess in our last interview with Don Curry a few months ago, the CEO of Hillcrest, he outlined how the company's soft switching technology offers increasing efficiency and cost savings for EV manufacturers. So this grid-tied inverter offers similar benefits then.
Correct. Yeah, they're very similar. They come from the same place. So the increase in efficiency and the better signal quality allow you to do things better than an existing inverter. So existing inverters are what we call hard switching inverters. And so the hard switch inverters is kind of what's out there now, pretty much everywhere. And so what we're saying is if you use a soft switched inverter, a ZVS enabled inverter, you can do your conversion at a higher efficiency. And so just like you do it in an EV, you can do that when you're trying to put power onto the grid from a solar farm. So higher efficiency. You also get to save a bunch of money because you don't have to put in as much hardware to work around the inverter. So you need less filtration and capacitance, inductance, all these things that don't matter to most people, but these are things that engineers have to do normally. And with the ZVS inverter, you have to do way less of that. So you save money installing it and putting it in a system. You can also get higher power density, which means same power, smaller box. You can also get reduced cooling. So, you can save money that way and smaller footprints. So there are a number of good benefits that do apply in EVs, but apply slightly differently in Grid Connect, but all coming from the performance of a ZVS inverter.
Right. And Hillcrest is the first company to kind of bring the soft switch technology in these sectors hasn't been implemented before.
Yeah, the concept of soft switching has been around for a long time. It's been contemplated. We're the first to be able to come up with a real commercial prototype, and that's the big step.
Right. Okay. So that's your recent news then. So this is the testing that you're doing now in
So
terms of, yes.
yes, we've done that in EV world, and now we're doing that in the Grid Connect world. So we're working on testing our proof of concept right now for that.
Very exciting. And assuming all goes well with this testing, how will this be, I guess, rolled out into the market with so many different applications? How will you prioritize which you pursue first?
Right. So in some ways it's going to be opportunistic, relationships and market urgencies and capital allocations and program timings do a lot to determine where you go first, second, and third. But generally speaking, we're looking to deploy it first in markets that are where they can really take advantage of our power density and scalability, um, and along with the efficiency. So, like a solar farm connected to the grid, a lot of need for that there, and a big benefit because of the large scale. So, a 1% efficiency improvement in just getting power to the grid, just that alone, multiplied by hundreds of megawatts, is a lot.
That'll
And
get
so
that'll get their attention.
yeah, and then the next thing would be high performance applications where the high switching frequencies and motor control benefits come from ZVS. So people doing embedded motor control applications like in industrial applications, which are everywhere, pumps and fans and compressors all over industries. That's another area where we can add some value. And then also chargers for say EVs or for UPS systems like backup systems for data centers and that sort of thing. So there's a number of applications, and those would be some of the key ones.
Right. I'm assuming that once news of this sort of this technology testing going well, your phone's going to be ringing off the hook.
We expect so. Yeah, and we do get a lot of interest. We do, and that's partly how we select partners. And
I can
you know,
imagine. Yes,
yeah.
it's an easier sell when they're coming to you. Before
Mhm.
we wrap up, can you give us a quick burst on what's on the horizon for the next few months? What are the next steps then in the commercialization of this
Yeah.
technology?
Perfect. So the first thing we have to do is finish this proof of concept. And so the proof of concept right now is a scaled down version of a grid connected ZVS inverter. So it's the other ones we've done were for mobile applications. So this one is now having to operate in conjunction with the grid. So there's communications and there are standards of connection and all those sorts of things. So we're going to prove that out, and we're just about there now. So we'll have the first ever ZVS enabled grid connected inverter. And then the next step is to do that at a larger scale. And in these kinds of markets, because of the maturity of markets and channels and producers, we're going to do this with partners. So OEM partners. So when we go to do our commercial prototype for that market, it'll be done with a downstream partner. They'll tell us, the specs that we need to get to and so on, and we'll do an integrated field test with them to meet their requirements. So that's what comes next, and we're looking at doing that in the first 2 quarters of 2024.
Wow. Okay, that's coming up very soon then. Well, that's a great strategy, obviously, to turn the testing partner into a customer right after
Right.
that test wraps up. Well, that's very exciting, James. Thank you so much for this update. Such an exciting time for the company, and yeah, we look forward to continuing to follow the story.
Thanks. Appreciate it.
All right, bye for now.
Bye.